can start. I heard my echo for now, so please, yeah, it's okay now. Thank you very much. So, as you can see on the first screen, this talk will be about some topics on VR Developers Conference that was held in June this year. That was a very interesting conference with many interesting talks, speakers, and so on. It was attended by around 10,000 people from all over the world. You know, when tickets is not so expensive, we have so much people and so many interesting faces and so on, as you can see on the screen. So before I start talk about some more concrete, I would have one question for you, and that is, have you ever tried to create a hybrid app that looks great and works smoothly on all devices? I know we are pretty much full of backend developers here, but there are some front-end as well. So I'm not sure what was your experience regarding hybrid apps until now. Does anybody of you has such experience? Maybe. Generally, problem with hybrid apps is that they can work slowly on some devices, pretty much mobile devices, because they are hybrid apps are applications which are which have just one code. And it is actually a web application which can be installed on many devices because when we use some frameworks like PhoneGap or React Native or something like that. So the thing is that they don't communicate with the operating system directly. They communicate via browser's web view. So that slows down a little bit performance because there is a delay on user gestures or if we need to show some complicated graphics, we have many animations, so on. That's not so fast when we have hybrid application. So React Native maybe gave some solutions for that, but that's not so perfect. So there is a question, is that really possible to create a hybrid app that would work fine on all devices that does matter? So yeah, the answer is yes, finally, and thanks to the Flutter. I'm not sure, have you heard about Flutter until now? That's pretty much a new framework, but I heard for it on this conference for the first time. If I'm not mistaken, the first release of Flutter, official release, was in January this year. Correct me if I am wrong. So, okay, why Flutter is so good? It provides very fast rendering on all devices, so over 60 frames per second. It's productive because it offers fast hot reloads. So as you change your code in your editor that is being reflected in your browser, you see in no time those changes. Something like we have in Angular, for instance. It has many very beautiful user interface, and that user interface is very customizable because you can edit every pixel on that. So whatever your boss or your client wants from you to do, you can regarding widgets. And yes, it is free. You can download its open source code, and you can even contribute if you are interested. Why not? Flutter uses Stia. So Stia is a 2D rendering engine. It is used by Chrome. If you noticed, I'm not sure if you made some comparison between, for instance, Chrome and Firefox. I recently did that. I noticed that animations in Chrome are going faster than in Firefox. Maybe that's not the general case, but what I noticed, from what I noticed, yes, it is. It so allows the user to run apps in high performance, and as I mentioned already, every pixel can be changed. And Flutter also uses Dart. Dart is object-oriented programming language. It is developed by Google. Stia is also developed by Google. So it's very easy to understand because it's more or less a mixture of Java and JavaScript. You will see that in some code samples that will come later. It's strongly typed, something like TypeScript, for instance, but also flexible like JavaScript. Why it works so fast? Because it compiles to JavaScript or native ARM or ERS64 codes. That means that there is no mediator between your code and device. It compiles directly into native code, and it works like it is a native application. That's new on the market, and nothing before Flutter had that possibilities. Here are some basic types. In Dart, you can see nothing special. We have some array-like structures like list, set, map. I'm sure you already saw something like that. There is a very interesting structure, duration and the stopwatch. So, for instance, for the time, we can start stopwatch and stop it later and see how much time did pass. There is also var keyword like in JavaScript. So you can use that, but it's generally not recommended unless you really need it, because you know it's always better to get compile errors. So in the compile time, than to have those errors later. So Dart provides two types of compilation, like in Angular, for instance. We have ahead of time and just in time. One is for production, one is for development. For sure, ahead of time is optimized to work fast. You don't need to download compiler because it's already compiled for you. You just need minimized code, nothing more than that. Just in time, yeah, you need to download the compiler. Actually, the compiler is being downloaded when you run the application. And it's you know, when you the code is not being compiled until you really need that, because you can run one load the first page if the code for that first page will be compiled, and once you go to the second page, then that code will be compiled, and so on. So we have flexibility regarding that. The most famous editors which support Flutter are Visual Studio Code, Android Studio with emulator, and IntelliJ IDEA, but there are probably some more of them, and in the future will be much more, I'm sure, because it seems the Flutter is the future of hybrid apps. So, okay, enough with theory. How does it look in practice, let's look into this example. We have one simple code in Visual Studio. We have a main.dart file, and you see, because in Flutter almost everything is widget. What is interesting, Flutter doesn't divide template styles and logic and data into separate files. You can see all of that here. So center is actually a widget. Flutter demo is a text which will be shown in that widget, and it looks like this. So nothing special, you will agree with me, but that's some most basic. If we want to maybe beautify it, we will add some colors, we will increase the font size. In that case, we need to use material design, also stuff made by Google. So Dart is using material design for designing widgets. And how does it look? It looks like this, much better. Yeah. So let's go further. Everything you saw in the last slide can be wrapped into a widget. So as you can see, we have a main function like we had before, and we are just providing the demo app widget to run app function. So the whole code is placed now into demo app widget, which extends stateless widget. In Flutter, you have stateless stateful widgets. That's indication for performance, because a stateless widget can be rendered just once. Data in that widget cannot be changed. So it will be not rendered more than one time. So the code is the same, and for instance, this is maybe not so zoomed in, but I will show you later. We have this. We have here a greet user function. So here, and this function is called just to create that dynamic text that will be shown to the user. So this is zoomed in. So it looks like this, nothing special. In dependence on the part of the day, appropriate message will be shown. So when I took a screenshot, it was evening. So it says just good evening, and that's that. You see, Flutter provides some mechanisms for fast writing code, and that's why is he also very popular. You can immediately see what you did without so many lines. If you are interested now to learn more, there are some interesting links. Especially for me is interesting for me is the second link, because Flutter has started the contest for developers. They said, hey, can you create an app which is less than 5 kilobytes in Flutter? And there are many nice apps there, and you can check that. So that's about Flutter. Do you maybe have any questions related to this part? Because we will talk about one more topic. If there are no questions, I will go further. So The other topic is when testing makes no sense. That's a presentation held by Miro Svrtan. That's a senior software engineer from Croatia. He has many presentations in his career. So maybe you had a chance to listen him on some conference or something like that. He presented something about writing tests in a very interesting way for me. That's why I decided to share it with you. I would again start with one question. So how much time do you need to fix a bug on a simple website and to deploy the new version? If that website is not so complicated, so maybe it doesn't have so complicated functionality, not so many pages, I guess you wouldn't need so much time to fix it. And as soon as you upload your changes, users will be able to see the new version, and actually answer is not so much time, right? But how much time do you need to do the same for Android or iOS application? We have a different environment now, so you know, when you want to submit something on Google Play, how much time will pass until users download your changes? It can be days or more. And what if you have some important bug to fix? Maybe you will waste so much time or even money. But okay, when we should write tests? That's the question. Because maybe we don't need always to write them. There are many opinions, but one of them is maybe when the cost of fixing is greater than the cost of testing. Sounds good. So you need to see what will you get and what will you lose if you write tests. What would be cheaper, to write tests or to fix bugs? That's something that needs to be analyzed. And should we test the web app, since we can quickly fix and deploy it? Why to test a web app if we don't need so much time to fix that? Maybe if it brings a value. But as I mentioned, what's the value actually? Value is benefit minus cost. So what will you get minus what you will lose? And benefit is not just the money. Despite people mostly think about money, people are benefit as well. Because it costs a lot to find a replacement for a good developer. Why? Because a good developer, maybe it wouldn't be interesting for him to just resolve issues in your application and to not work on features. So who wants to work on an app that has more issues than features? So writing tests is really good for employee retention, right? So there are some of testing policies. What people usually think why writing tests is not good, or why is good. Let's start with the first one. It says it makes my project more expensive. Definitely, we cannot disagree with that. You need to invest some time and so on. But when you develop, you do manual testing as well. You don't count it as an additional task, right? So we always need to test in one or in another way. Bugs cost as well, because if the app is not properly tested, we will have bugs and we will need to fix them, and our customers won't be satisfied and so on, and that can charge a lot of money maybe. And please, from your side, one interesting topic for thinking is, would you rather buy a well-tested car that costs $20,000 or a cheaper one that costs $5,000 but not tested? I'd rather wouldn't buy any car, or would buy the first one. I don't know for you, but that's my choice. Policy number 2, it costs a lot of time, definitely. But like in programming, you know, when you was a junior, you had to spend much more time than now when you are senior, for instance. So for the tests, that's same, and we need to distinguish between learning how to test from testing. So definitely we need to invest some time into learning, but that's normal. It takes extra time. Definitely, they will spend less time without that, but manual testing takes extra time as well. And you know, when you once write tests, they are being executed very fast. But manual testing, which you need to repeat always, it is not so fast. So it's a policy, definitely. 100% code coverage. Yeah, many people think that that resolves everything. Oh, our code is 100% covered. We are happy. We have all tests. So, yeah, we can easily know what haven't been tested. But maybe that's not all, because even we have 100% of code coverage. That doesn't mean that we have been tested everything. And the other point is that it would be good to skip some simple parts of the code, like getters, setters, trivial functions, and so on. So there is code that really doesn't need to be tested. So when we have on our mind that code coverage does not equal to test quality, and that we don't need to cover every line, then we can conclude that 100% of code coverage doesn't mean so much. It does, but we need to make quality tests, and code coverage cannot say us did we do that or not. Okay, so policy number 5, writing tests later is okay. Let's, for instance, create an application, and we will see later when we put it into production what will be the bugs and so on, and we will write tests for that bugs, and they will not happen again, and so on. Usually developers wouldn't like to write them later. They will just do that to fill up the code coverage, what happens in the most situations, and also our customers will not be happy, and so on. Policy number 6, we have tests. What does it mean? Yeah, great, we have tests, wow. But what is the quality of those tests? what's their value? What cases do they cover? Do they cover some exceptions, some errors handling, some cases about we cannot think we cannot think about those cases maybe while we are writing the code, because those cases are maybe not related to our code lines. Generally, yeah, they are, but not so. That's not in the first plan. So, okay, that's about policies. But what are benefits of writing tests? There are some interesting benefits, and one of them is easier onboarding. Why? So, for instance, a new developer feels much more comfortable with the code he has to change, especially if it is in a big project. Why? Because he don't need to be afraid. He doesn't need to be afraid. Will he break something else? So we have tests, and if he accidentally breaks something else, our tests will show that, and he is much more comfortable. Also easier to add new features. Why? Well, for the same reason, right? Because we are sure that the old features are still working properly. Easier refactoring. When we refactor code, that could be very, very tricky if we produce a bug, because you know, you are changing so many code, and you will need maybe more time to investigate what change exactly has produced that bug. And also easier rewriting for the same reason. If we want to rewrite some parts of application, we are sure that everything else works fine. Cleaner code, that's very interesting, because imagine that you have a function with, for instance, 200 lines and 7 if statements. Would you like to test it? Would you like to take into account all those if-else statements, all those cases? No, for sure. So you will write cleaner code, better code that will be easier to test. Okay, and that was about benefits, but when testing doesn't make sense, maybe, yeah, there are some cases when it doesn't make sense. One of them is when you write a small app. If you have never tested before, don't learn to test. Don't learn to test just because of that small app. Not needed. Really, it will be quicker for you to test it manually. Also, one-off app. If you are creating an application just for a single event, like for some conference, and nobody will not use that application after that, maybe you can write some tests, but don't write a lot of tests, because you will lose more time than you will get some benefits from that. And there is one more interesting reason. Maybe you haven't thought about that before, neither me. But if you want to keep your job, then don't write tests. Why? Because imagine that you are, for instance, the only person in your company who knows how to fix bugs, in some old projects. And you don't want to change the company. Yeah. So you will always work for that company. Nobody will want to fire you or something like that. No chance. So please don't write tests in that case. But if you want to be competitive, then write them, because many good companies request knowledge of testing from candidates. And that's the fact, and that's something related to modern applications. Almost every good application has also very good tests assigned to it. And generally that would be all from my end. I hope that it was interesting for you, that you maybe have learned something new from this presentation. And if you have any question related to it, please feel free to ask. Okay, if there are no questions, I would like to thank you very much for listening and not sleeping during this presentation, and have a nice day.
Thank you.
Thank you, Miroslav.
And do not test. Thank you.
Great to hear that. Thanks a lot. Bye-bye.
Bye.